Alternative sources of energy. It's what we need to do this. And this. It's how we get heat from this. And from this. It's all about energy. While energy can be used as the strength and vitality required for sustained physical or mental activity, today's lesson we are going to be talking about the second definition, which is the power derived from the utilization of physical or chemical resources, especially to provide light and heat or to work machines. Take a second to think about what that definition means. What are some sources of energy you can think of? Feel free to write your ideas in your notes so you can compare what you knew before to what you are about to learn. When you thought about sources of energy, did you think of non-renewable or renewable sources? These are terms you may have heard in previous science classes, but if their definitions aren't quite coming back to you, I'll give them to you here. Non-renewable energy sources do not form or replenish themselves in a short period of time. Examples of this are crude oil, natural gas, coal, and uranium for nuclear energy. You should have learned about these common sources of energy before, so we will be focusing more on renewable, sometimes called alternative, sources of energy. If non-renewable sources do not replenish quickly, what do you think qualifies a resource as renewable? Can you think of any examples of sources of energy that might be renewable? Renewable energy comes from sources that are constantly replenished naturally and will never be exhausted. The sources of renewable energy are derived from natural processes such as the sun, wind, water, biomass, and geothermal. Solar energy harnesses its power from the sun. Photovoltaic cells on panels capture sunlight and have the ability to convert this energy into heat, electricity, or chemical energy. Just 18 days of sunshine on Earth has the same amount of energy as is stored in all of the planet's non-renewable resources. While solar power is controversial in the amount of available sun because of weather like this, the entire surface of Earth averages 4.2 kilowatt hours of energy per square meter per day. That's the equivalent of 1 barrel of oil per year. Summarize. According to this map, which would receive more energy, Washington State or Florida State? Why? Wind energy works to harness air currents and convert this power into usable energy. Wind power is one of the most abundant resources available and is an increasingly cost-competitive resource, making it a strong competitor to fossil fuels. This source of power has been used for centuries to sail ships or turn windmills for grain, but beginning in the late 1800s, early 1900s, farmers began using windmills to pump water before electricity reached rural parts of the U.S. Now, decades later, the U.S. wants to come back to wind power in order to supply that electricity. While the speed of wind, how often it blows, and when it blows can all have an impact on the effectiveness of wind energy, the cost-effective nature and cleaner carbon emissions are pushing the U.S. companies toward the expansion of the wind energy market. Summarize. According to this map, where are the best places to harness wind energy? Geothermal energy utilizes the heat from the Earth. Contrary to popular belief, geothermal heat is not just found deep below Earth's crust, it can be found in the dirt in your very own backyard. Typically, though, this resource is found in most abundance along tectonic plates or hotspots for Earth movement. In Iceland and El Salvador, geothermal energy accounts for 25% of electricity produced. Summarize. Do you think more geothermal energy would be available around a volcano or in the middle of the prairie? Why? Hydroelectric and hydrokinetic energy both have to do with moving water to create energy. Hydroelectric specifically has to do with harnessing the movement of water to create electricity. It deals more with water's potential energy. This source is reliant on rivers and streams, therefore it may not be available everywhere. When you think of hydroelectric energy, think of Hoover Dam. The dam was created in order to utilize how stagnant water moves due to gravity, utilizing its potential energy. The natural movement of water is powerful, and that is what hydrokinetic energy works to utilize. This source focuses more on the kinetic energy of the water as it harnesses the motion of water like tidal waves and river currents. This source can provide enough energy to power 67 million homes, but while hydropower energy does not emit air pollution like fossil fuels, it still has negative impacts on the environment like degrading water quality and hurting fish populations. Summarize. What's the difference between hydroelectric and hydrokinetic energy? Biomass is used to describe plant matter and animal waste. Biopower is then the use of biomass to generate electricity. This resource is renewable because it gets its energy from the sun and it can regrow over a rather short period of time. Like other resources, biopower has environmental risks if it is not well managed. Several studies have shown that biopower has little to no economic gain because of high cost, low yield, and therefore is not the fastest rising alternative energy source. Summarize. Where does biomass energy ultimately come from? While non-renewable resources account for 85% of our energy in the U.S., these resources are rapidly depleting and are unable to replenish themselves in the immediate future. Renewable, alternative energy sources, on the other hand, will never run out and therefore could be used for an infinite period of time. Wherever you take your notes, please summarize the alternative sources of energy explained in this video in one sentence for each source and prepare any questions you might have on this material for our discussion tomorrow.